Um, Today I will introduce to image processing with MATLAB. The lecture is divided into two parts. In the first part, I will still introduce some themes related to MATLAB. In the second part, I will introduce some basic themes and some examples for image processing use MATLAB. First, I will introduce MATLAB basic themes. We already learned some basic plot function. Today, I will continue to talk about this one. So, for plot, its major use for visualization. For example, you have vector x and another vector y, but the vector x and the vector y have the same dimension, and y can be treated as a function of x. Then you can just plot x, y. Also, you can directly plot some function. For example, you want to plot the function sin x. Then you can put plot x sum x here. But first, you need to create a vector of x. For example, from 1 to 2 multiplied by pi. That's the range for x. Then sum x also will be a vector. Then they will plot the function. Let's see the MATLAB example. I already opened this MATLAB here. For example, you want to set x from to 2 pi, 2 multiply. Then you create about 2 pi, create 100 points, divided by pi. That means the x value, let's start from 0. The x value from 0 to 2 pi, and the value between 2 points will be 2 multiplied divided by 100. So you create x. You will found the dimension of x. I'm sorry, should move the 0. So it has 101 points. That's x. See here. Then create plot x sum x. Sum x. See here. That's the sum function. So that's for the plot x sum x. Also, you can plot x cosine x. See, that's cosine x. Also, you can plot x sum x multiply. Be careful here. This multiply should be dot multiply. Cosine x. Then let's see. I'm sorry. We should push here. That's sum x multiply cosine x. So that's use the plot. Also, you can plot the x, y. For example, y we already talked last time. Y equal to sum x. Y also is vector. If you check the dimension of y, should be 101 vector. You also can find the exact value y. By tap this one. See. So you can direct plot x, y. So that's show plot x, y. Let's go back. That's for the plant. Also, we already talked about the figure K. We will not talk about it in detail here. Just you need to know it's open a new figure. For the fig, also there is a hold on and hold off function. For example, let's go to here. We can create a figure 1 here, okay, figure 1. Then we plot x sin x, okay. Let's see, did you guys see figure 1? That's sin x. However, when you also want to plot x cosine x overlap with this sum x, then you use the hold on first. Hold on, that's when you show the next plot, they will keep all the feature here. Just add the new figure on this figure. Let's see. We put hold on, then we plot x cosine x. Let's see the difference, okay. Cosine x. If you open the figure 1, see, that's sin x, okay. That's cosine x. That's use hold on. They will add the new figure to the old figure. However, if you don't want to use hold on, for example, for the plot sin x multiplied by cosine x, you just want to plot, replace the old figure, okay, don't overlap, then you can put hold off here. Hold off, that means don't hold it. The old figure just will not be there if you plot the new plot. For example, let's see now. I'm sorry. Let's see now. It's here, okay. You already use hold off. So if you plot x cosine x multiply sum x, then you guys will see. Now we see the sum x cosine x here, but we use hold off, then plot. This two figure will be disappear, and the new plot will be show up. Let's see. See guys, the old sin cosine graphic disappear. The new one cosine multiply sum is show up. So after they hold off. If you want to hold on, you still can go hold on again. For example, you add another one, okay? Plot sin x sin x, okay. See, then two figure will be shown there, okay. This is sin x multiplied by cosine x. This is sin x. Also, you want to plot x cosine x, because you already used the hold on, you did not use the hold off, so they will overlap. Let's see here, yeah, cosine is here, so they will overlap there. That's how to use hold on and hold off. Beside the hold on and hold off, also we have many other choices when you display the figure. The first one is axis. Axis is just make the minimum and the maximum of your coordinates. For example, I can set the minimum of the x-axis with 0, then max value will be 100. For y coordinates, minimum value will be 0, y coordinates maximum value is 100. Then you can set it as follow. Okay, if you guys see here, this is from 0 to 1, 0 to 7. Okay, then you can use this function. Okay, you can just copy here. Okay, copy here. Okay, then put the minimum should be for example, put 1 here. Okay, because 0 you so then put 10 here. Okay, that's x 0 to 0.5. Okay, to 1. That will be good. Okay, then see, you see something here. Okay, the x is from 1 to 10. Y is from 0.5 to 1 because the maximum of this one is 1. That's use the axis. Another is the subplot. Subplot, that means one figure. For example, you create a figure 1 here. You not just show one image or one graphic. If you want to show multiple image in one figure, you can use subplot m multiply n by p. For example, when m equal to 2, n equal to 4, that they will show 4 images. Okay? If p equal to 1, they will show here. If the p equal to 2, they will show here. P equal to 3, they will show here. P equal to 4, they will show here. If for the m equal to 3, n equal to 2, then they will show 3 by 2, 6 image or plot. Okay? For example, if the P1, they will show here. Okay? P2, they will show here. P3 show here. P4 show here. P5 show here. P6 show here. Okay? Let's have some example. The first example is here. Okay? For example, I just want to the m equal to 2. So they will create 4 places for you to display the image or plots. So for these plots, okay, because the p equal to 1, so these plots, I hope it will show here. So for these plots, y equal to sum 2 multiply x plot x y2, then the subplot 2 will show here. Then the y3 equal to sine 4 multiply x, okay, plot x y3, they will show p equal to 3. Then for the y4 equal to sum 8 multiply x plot x y4, this figure will show p equal to 4. Okay, so the easy way just copy the stuff, okay, to test on the MATLAB. Okay, first we just close it, then create a new figure. Okay, we call figure 1 again. Okay, it's show here figure 1. Then you just see here. Okay, we just run these codes. Okay, let's see. Okay, see here. Subplot 1 show here. Subplot 2 show here. Subplot 3 show here. Subplot 4 show here. That means one figure can show 4 plots. That's for the example. Also, we can show more figure. For example, if we have 6 plots, I want to show one figure, then you can create a grid 3 by 2. Okay, so we can create 6 plots. Okay, when p equal to 1, this figure will show here. P equal to 2, this figure will show here. P equal to 3, this graphic will show here. Okay, when p equal to 4, they will show here. Then p equal to 5, they will show here. And p equal to 6, we should still have 6 here. Then they will show here. Okay, so that's we plan to do. Okay, so we also can copy this code, then run. You can copy. Okay, copy the whole code. Then let's see the results. You still close the fig. Create a new fig 1 or something. You can create the name you like. For example, figure 10. They show figure 10 here. Okay, then just run. If you see the figure 10, see here 1, 2, 3, 4, 5, 6. Create 6 graphics here. Okay, that's one figure can show 6 plots. That's for the plots. Also, we can show image. For example, you have 4 images, okay? 4 images. You want to show the first image show here, the second one show here, the third one show here, the fourth show here. You can use the same way we show the plots. For example, I already have 4 images saved on my computer, okay? In fact, if you guys check my directory, okay, go to 10 teaching 2009, we have 4 images here. See here, color, okay, color 1, course 1, download JPEG, gray JPEG here, okay. We just show this 4 image, color 1, download gray, this 4 image. So I write a code like this one, okay. First, I read these 4 images into the matrix. So A1 matrix will serve the color 1 image. A2 matrix will serve the gray image. A3 matrix will serve the color 1 image. A4 matrix will serve the download.jpg image. Okay. After I read this image pixel value into these 4 matrices, then we just use the subplot. Okay. This will be show this image on this location. That's 1. Subplot 2 will be shown here. Then the third will show here. The fourth they will show here. Totally we have 4 images. So we create a 2 by 2 grids. First you need to definitely you need to create the figure. Okay. So you can copy it one by one. Okay. For example, go to the MATLAB. Okay. We just close this one. Then we create a new figure. Okay. Create a figure. See, the figure 1 is here. Okay. Show here. Then we need a read them. Okay. After that, display them. Display use this 4. Okay, just also copy it. Okay, just enter the end key. Then see, that show the 4 images in one figure. Okay, so that's tell you how to use a subplot. There is another important comments called save. For example, if you run this save my session, that's the link you can use. Okay, then everything in the workspace they will serve in this file. Also, you can use your name. Okay, for example, you can close this one. Okay, then this is called workspace. Okay, you can save the whole themes into the workspace. For example, you can save 10.mat. Okay, after that you save, you just clean there. See, the workspace, nothing is there. If you type A1 now, they will tell you it's not defined. Okay, because I already clear out them. However, you save everything in the town.mat. You see here, town.mat is already shown up here. You can use the load to load the whole space. Just show here. Okay, just show here. Okay, you can load out. For example, load pen.mat. Okay, see, the workspace is shown again. Then you type A1, there is value here. A2, the value also is here. Okay, and also I. Okay, that's I use this one things when I prepare for the class. Also, there is a X1 you can show. Okay, If you don't want to use them, you can use click clear all, then the workspace is gone. So just how to save and clear the workspace. Also, sometimes you just want specially clear just two variables, not clear all the things, because in the workspace, for example, let's first load the town mat. Okay. Sorry, load town dot mat. Okay, see the whole world seems here, but I don't want to something. For example, I don't want I, so you can specially just clear I. Okay, so the I will gone. Okay, if you type I now, they will not defined. Okay, that's the big I, not the small one. Okay, no. So also, if you want clear A1, see A1 will gone. So if you type A1, it is not defined. So you can also clear clear A2, A3, clear 2 or 3. Okay, see. I'm sorry, A3, clear A2, A3. See, okay, you don't need to put the comma there. Okay, clear Y1, Y2. Okay, then Y1, Y2 disappear. Okay, after you clear, then if you type I1, Y2, they not exist. Okay, you can use clear all, then all the workspace is gone. So that's for the clear and the load and the saving. Also, the bunch of MATLAB useful functions. Oh, we already use the size I. Size as it just get the size of a matrix that we already use. It's also we have a sum. Sum is used to add the elements of a vector. Okay, if for a matrix you have to use this way. Okay, sum. Okay, then sum I. There are two sum here because it's two-dimensional. If a three-dimensional matrix, you need to use 3, or you can use sum I then colon here. Okay, that's called the sum. Mean, you compute the mean of vector the same as compute the sum of the vector. Okay, also mean I. Also compute 2D images mean. You can use mean, or mean, then put colon here. When you compute the median, the same. Okay, let's test. For example, we load the town mat. Okay, then everything here. For example, you want compute the mean of I. Okay, because I is vector. So equal to 1.5. Okay, see here. Also, we can sum I. Then it's 3. Okay, median I. What's there with median? Okay, 1.5. Okay, if you want to compute the matrix A1, okay, A1's sum, see, is this one. Okay, but A1 is a three-dimensional, so you still need to use sum, and sum A1. That's will get the whole sum. Okay, is this one. The same for the mean. Mean A1. Okay. Also, you can for this one. Okay, for the two-dimensional, you can use mean A2. Mean A2. Okay, that's for the two-dimensional, because this, you see this, the A2 is two-dimensional. Okay, the same you can use it for the median and sum. Also, there is a note of other function here. For example, it's empty to test whether this is empty or not. For example, if you test now, they will return 1 or 2 or 0. They return 0, that means it's not empty. Okay, if you put it as empty, you can do this way. Okay, put it like this one. Now I is empty. If you call this function again, okay, you just copy, then paste, then they will return 1. That means the I is empty now. Besides this one, found the indices and elements in the matrix, you can use the found. For example, in this two-dimensional, you can find the coordinates. Okay, x, y equal to found. Okay, a2 more than 254. Okay, let's use this one. Use the uppercase y. Okay. Okay. Now if you type x, yeah, see, you get the coordinates. That's when x equal to 21, y equal to 22, that's value will more than 254. Or for the second pair of coordinates, this point also, these elements also more than 254. Okay, for this one the same. So we have bunch of pairs of coordinates. Their elements in this kind of coordinates, the value are bigger than 254. Besides one, also sometimes you can use some function reshape, okay, to change the matrix dimensional. For example, the original matrix is 10 by 10. We can change it to be 100 multiplied by 1. That means this is a rectangle matrix. We can change it to a vector. Okay, let's create a small matrix. Okay, that's easy to 1, 2, 3, 4, 5, 6. Okay, then 7, 8, 9, 10, 11, 12. Okay, so the size of A you will find is 4 by 3. Okay, so you can create a 3 by 4 matrix. Okay, use reshape A, then okay 3 by 4. Okay, let's see the grammar. Okay, the grammar is here. Okay, okay, I'm sorry, we can use b equal to reshape A. It just reorganize B. Okay, so B equal to this one. Let's see A. Okay, see, this is A. This is A. It's 4 by 3, but B is 3 multiplied by 4. Okay, so in fact they reorganize A's matrix into B. See here, B is 1, 4, 7. 1, 4, 7 the same, but the 10 moved here. 10, 2, 5. Okay, then 8, 11, 3. Then 3, 6, 9, 12. Just from the top to bottom. Okay, when they reorganized. Also, there are other functions. For example, the exponential and logarithms of x. Okay, this is a vector. Then this one should be exponentials of x. They will create a vector. Okay, we can test. For example, x equal to 1, 2, 5. Okay, x5. Then axp x. Okay. Oh, I'm sorry. Yeah, it should be this one. Okay, because we have uppercase here, it's not correct. Okay. Also create a vector, but the first element equal to exp1, the second equal to exp2, the third equal to exp3, and the fourth equal to exp4, and the fifth equal to exp5. Okay. Besides, we have many other functions. For example, for this function also it works. For this two, I will not teach here. This is a very complex here. For this one, perhaps I will teach in the future. Okay. So